All right, so I got a few email requests today. Well, I'll say just a few. I got a couple of email requests today. So the first email request, this is from Elijah, and he wanted me to ask me. He asked me to go over the discussion board for this week for Organic 1. So let me bring it up on the desktop. Wrong software. There we go. So the question is how you name these particular compounds. Now, alcohols are actually a lot easier to name than your traditional alkane for two reasons. First of all, the alcohol has to take top priority, so it's going to tell us what the lowest number carbon is. It's whatever end of the carbon chain is closest to our alcohol. The second is that oxygen has a heavy atomic weight. It's heavier than carbon, and so even with the halogens, it makes it a lot easier to figure out when we start doing RS notation. So, few comments. First of all, this RS notation only appears if you have a chiral compound. So when we see something like compound number 1, this isn't a chiral compound. If we look at this carbon, it's got a cyclohexane ring going one way, cyclohexane ring going the other way. So this compound is not chiral. We just simply have to name it as is. So let's follow the naming procedures that we had for, let me bring up a document for you so I can actually type out what I'm saying. So how did you name alkanes to begin with? Well, we named the longest parent chain. So let's go ahead and do that. It's cyclohexane. Now, what we have here is an alcohol, so a cyclohexanol, and we have a methyl group. Now, because the alcohol is the main designator here, is the one that we try to minimize, we're not going to need to number the hexanol position. We just need to label the methyl. So this ends up being 1-methyl cyclohexanol. For the next one, longest carbon chain. So 1, 2, 3, 4, 1, 2, 3, 4, 5. So it's a 5-carbon chain. So butane. It's a pentane, but it ends with an ol. So LOL. We want to put the end of the carbon chain closest to the alcohol. So it's going to be 2-pentanol. And we have a methyl group. So it's 3-methyl 2-pentanol. Now I did have someone ask me today in lab, is there anything more right or more wrong with doing the 2 within the name of the alcohol or the 2 before? So let's ignore this methyl group and let's say we had 2-pentanol versus pentane 2-ol. If we don't have any other functional groups, we typically use that numbering system first, and it's simply for how it sounds and how it flows. So 2-pentanol is easier to say than pentan 2-ol. The reason why we have this notation and the reason why you're learning it here is that let's say we had an alkene. So let's say we had the alcohol here and we had an alkene between the 3rd and 4th carbons. Well, the ending here would be a pentene, and we'd have to put a number out in front to tell us which one was the start of a double bond. So again, if we had a double bond between this carbon and this carbon, it would be 2-pentene-ol. So if you know how to name alcohols by both ways, then when you start getting to these ones where there's multiple functional groups, it gets a lot easier to start doing the naming. But as far as this one goes, it's 3-methyl 2-pentanol. So let's go to number 3. So number 3, and I actually need to change this one because it's actually kind of a weird one. Really the longest chain here is a 5-carbon chain, so we're going to pretend it's really the 4-carbon chain. We're going to do the butane or butanol. So alcohol is going to start on the parent chain, so it's a 1-butanol, and as far as things that are off of it, we've got a bromo and we've got an ethyl. So our bromine here is on the 4th carbon, and our ethyl is on the 2nd one. For the next one, we have a cyclopentanol. Now, we don't need to specify the position of the alcohol, but we do have a methyl, and it's on the 2nd carbon. And it's going to be the 2nd carbon because the alcohol is going to have to take the primary position. Now, there is stereochemistry here. These are chiral, so we can do the RS, or if we look at it, there's also a hydrogen on this OH, on this carbon with the alcohol, and there's a hydrogen on this methyl group. So we can also call this trans 2-methanol, or if we want to refer to the higher priority groups, it would be the E2-methyl cyclopentanol. Now, for number 5, you've got a bromo, a methyl, and a cyclopentanol. And again, the alcohol is going to take priority, so you don't need to specify its position, but we do need to specify the positions of the bromo and the methyl group. And because we do have two chiral centers here, we do need to specify stereochemistry. Now, we can do the R and the S, but really the EZ is going to be the easiest one to do in this case. So if we look on the left side, or if we look between these two, the OH group has the lower priority than the bromine because the bromine has the higher atomic weight. So on this side, the higher atomic weight's on the wedge. On this case, the higher atomic weight's on the CH3. So this ends up being Z, zusammen, bromo, Z, 1 bromo, 2 methyl, cyclopentanol. Now for the last one, this one you're actually going to do stereochemistry, but again, go with what you know. We have 1, 2, 3, 4, 5, 6, 7, 8. So this is octanol. We're definitely starting on the first position with that alcohol. And we have a methyl, we have a chloro, and a methyl group. So we need to specify their positions first. So the chloro appears on the 1, 2, 3, 4, 5th carbon. The methyl group appears on the 2nd carbon. And now we're actually going to have to specify stereochemistry. So we're going to have a 5, a 2, and a 5, and we need to designate RS. So if you look at the first one, it's bound to a carbon, a carbon, a carbon. These are two methylene, so your CH3 is going to be lower priority, so this is going to be 3. Alcohol is going to take higher priority. That carbon is going to take lower priority, so it's 1, 2, 3. Counterclockwise gives you 2s. And for this one, first point of difference. So chlorine is going to be number 1. That's going to be 2. That's going to be 3. It's actually backwards, so instead of being S, it's going to be R. So it's 2s, 5r, 5 chloro, 2 methyl, 1 octanol. So that's how you name these compounds. Again, don't overwhelm yourself. Start right to left. Name the parent chain and the alcohol. Name the branches. Recognize that you're going to minimize the number on the alcohol. So figure out where carbon puts the lowest number on the alcohol, and then start numbering everything else. If you've got stereochemistry, if you can get away with it, do the cis trans or the EZ. And if not, it's just the S and the R, but everything else should be labeled before you get to that point. The other question I got asked. Actually, I just asked those. So it was asking about the R and the S's for compound 6. Again, with 5 and 4, you can do the R and S, it's possible, but honestly the cis trans is a lot easier, and that's how they would be named anyway. And for 1, there's no stereochemistry. Any questions out there from people in the chat? Oh yeah, I forgot to update that. So yes, I just got to ask a question about the synthesis of aspirin. Has the synthesis of sulfonylurea, whatever that compound is. Yeah, I just need to update it. It's actually I should be able to update it now. 236 quizzes and assignments, lab assignments. Right. Give me just a minute. Content collection. verify this is the right file. Nope. Let's see if I've got it in my archives. I'll update the worksheet either today or tomorrow, most likely, since I don't carry my files with me to campus. But honestly, all you're doing is a percent yield, the TLC plate, and the melting point. And that's really about it. I don't think there's much to record for this lab. Can you draw number 1 as a line bond structure? I'm assuming you're referring to number 1 on the discussion board. That's already a line bond drawing. Yep, just remind me aloud today and we'll go over it. The hope for today is that the TLC plates work out. They should work out, but again, we've never done TLC of this lab before. So number 1, there is no chirality because there's no chiral centers. So if we look at number 1. So we have an OH and a CH3. Well, just because you have line bond lines and just because you have wedges and dashes doesn't imply that you actually have chirality. I mean, you have to have wedges and dashes if you have chirality, but that doesn't mean that there is one just because you have it. So the reverse is true. If you have chirality, you've got wedges and dashes, but if you've got wedges and dashes, that doesn't necessarily mean you have chirality. And the reason we know this doesn't have chirality is that if we look at this carbon here, and we look at what's bound to it, We've got an OH group, a CH3 group, and then we've got this ring going around it. And this ring looks the same if we go clockwise or counterclockwise, so there's no difference in the groups bound to this carbon. So because two groups are the same on this carbon, it ends up being an achiral compound. So again, one doesn't have chirality in it. It has wedges and dashes, but if you were to build that molecule and build its mirror image, you could just rotate that mirror image along the line connecting these two opposite carbons, and you would get the compound back. So that's why the wedges or dashes are in there, is to make sure that you're not trying to assign chirality to something that doesn't have chirality. Now, if these OHs and CHs, if that OH and methyl group were on different carbons, then yes, you would have two chiral centers. Yeah, you're welcome. Other questions? Correct. So number 4 in this case, the methyl was an example. I didn't even know, forgot it was up there. So number 4, the methyl and the hydroxide, or methyl and the alcohol functionalities on different carbons. So if you look at those carbons, they are different. So for the alcohol, there's an OH group sticking off one in the carbon, there's a hydrogen sticking off, there's a CH2 group sticking off, and then there's a CH group sticking off the other side. And you can see that with the methyl group. The methyl group is the same way. There's 4 different things around that carbon. Thanks, Lauren. I'll see you next week. right, so I don't have any more questions. We'll just go ahead and sign out for the day. Again, if you're on Orgo 2, remember your homework is due tomorrow by midnight, and your exams are due Sunday at midnight. Again, email me if you have any issues with the exams. Orgo 1, you're starting alcohols and alkyl halides. Welcome to the fun world of reactions on top of naming, on top of characterization and analysis. So I will see some of you this afternoon, and I will see all of you next week. Thanks for showing up.